How do you find your cation? So if you look at your periodic table, it is divided into two main groups. The representative elements, which are denoted by the group number plus the letter A. These are the transition metals, and in here you also have your representative elements. Okay, so everything in group A, you can know the number of valence electrons. And if you know that, you can also know there are charges. So for example, in group 1A, the elements belonging to group 1A usually have +1 charge or +1 plus. Okay, so let's write this is +1. Hydrogen can be +1 or -1. So if hydrogen is bonding with a non-metal, any of these guys, the charge of hydrogen is +1. So for example, you have lithium. The ion that lithium can form is Li plus, Na plus, K plus, Rb plus, Cs plus, Fr plus. Alright, no need to write 1, just like in algebra coefficients. Now in group 2A, their ionic forms will be having a charge of +2. So for example, Be2 plus or Be plus 2, Mg2 plus, Ca plus 2, Sr2 plus, Ba2 plus, and so on. Alright? Now in here, from boron, aluminum, gallium, although they can have many charges here, the usual is actually +3. Alright, so +3, so aluminum 3 plus, gallium 3 plus, indium 3 plus, and so on. In this corner, or in this column, we are now divided, so it can be either plus or -4. Okay, so if it bonds to a non-metal, the charge is +4. If it's bonding with a non-metal, it's usually negative. Alright, but take note that these can also have variable charges because they are post-transition elements. Okay, post-transition elements. So starting from here, As, Sb, they can have multiple, or Ge, Sn, even tin can be Sn2 plus or Sn4 plus. It's the same thing with lead, Pb2 plus or Pb4 plus. Alright, and then in here, the charge now becomes negative because in this area, these elements need 3 more electrons, and it takes lesser energy to attain or to gain 3 more electrons than to get rid of their 5 valence electrons. Okay, so look at, there are 5 valence electrons for these elements. Okay, so if they are bonding now, it's easier, it takes lesser energy to gain 3 more electrons than to get rid of their 5 electrons. So once they gain 3 more valence electrons, then their charge is usually -3. Alright, so -3. So these are now your anions, starting from the ones na there is negative sign. So anions here. So oxygen, starting from oxygen, you have 2 minus, and then halogen group is F minus 1, okay, Cl minus, Br minus, I minus, so on. Now the charge of the noble gases is 0, since they rarely participate in bonding except for xenon, because there are some observed compounds of xenon difluoride or xenon tetrafluoride. Alright, so again, the pattern is +1, +2. These have variable charges, but the most common charge is +2, and then these are +3, plus -4. After carbon, you have -3 charge, -2, -1, and then 0. Alright, so that is how we get the charges for the atomic ions that we had a while ago, okay, in these examples.